Hey everybody, welcome back to Kosmos. So I've enjoyed watching a few videos lately on YouTube about people's finds at kind of boot fairs or flea markets, and sometimes some real treasures can be had there, and I've enjoyed watching that. And I found myself at a fair recently. So because my interest is horological, I tend to go to the clock and watch fairs here in London, and sometimes you can find some really interesting bits and pieces, especially given the long history of clocks and watches in the United Kingdom. So there's still a lot of very old stuff to be found for really for nothing, and so I thought I'd show a few of the things that I'd come across. So the first thing, and actually this video will tend, I think, to be quite wheel and pinion centric, if you would. As it happens, a lot of things to do with gearing, horological gearing. So one of the most interesting things to me at this fair the other day was this object here. Now, this is a very interesting piece of material called pinion wire. So back in the day, we're talking mid to late 19th century at the latest, but stretching all the way back to the early parts of horological history. Clockmakers and watchmakers didn't generally have the means to cut steel pinions. So here we have a steel pinion of my own making, and you can see that it's been cut out of a piece of steel blank. And because I have dividing facilities and I have milling facilities, something like that is relatively straightforward to make, if requiring, you're keeping your wits about you in order to preserve precision. However, clock and watchmakers back in the day didn't have that luxury, and so they would buy pinion wire. And so this is a piece of steel material that's been drawn through a die, and so that's about 10 inches long, I think. Bit less, 8 inches, and that is a kind of rough form of pinion. And so the way a pinion would have been made, in the golden age of horology, would have been out of the solid. And so a piece of this material would have been procured and marked as to where the actual gear section would be, where they wanted along the length of the blank. So if that's considered to be a blank, bear in mind this is many pieces assembled. In old horology, except for the brass bit there, all of this would have been in one. So the arbor, the pivots, and the pinion would have all been made out of one piece of metal. And so you'd have cut this piece of pinion wire to length, and turned away these leaves. So in horological work, the gear teeth are called leaves in a pinion, and they're called teeth in the wheel. So you've got wheel teeth and pinion leaves. So the waste would have been turned away, leaving just the pinion itself. And then pivots would have been turned on it. And of course, this may not have been the ideal size, and so I'll show you something later about sizing pinions appropriate to the wheel that they had to mesh against or mesh with. So I've never actually seen a piece of pinion wire, and any piece of pinion wire you're likely to find is going to be very old and an artifact of history. And in fact I've seen once for sale on eBay some pinion wire, and it was outrageously expensive. I nearly bought it. I think that was like 30 or 40 pounds for a length like this, for a stick of pinion wire. However, at the fair I just went to, I was just rummaging through a rusty old box of bits on some guy's stall, and I found this, and I said to him, well, how much is that? And he said, well, you can have it for £2. So I said, yes, thank you very much, that's mine. Put it away and gave him £2. So to me that's of great historical interest, because you can really see how things would have been made before we had the sort of equipment that we have at our disposal today. So this particular piece has 1, 2, 3, 4, 5, 6, 7, 8 leaves. That's an 8-leaf pinion. The clockmaker might deepen the spaces with a file, or by grinding somewhat. You'd buy pinion wire like this in different diameters, and also with different numbers of leaves. Bear in mind there's not an infinite number of leaves that you would require for horological work, because horological wheel work needs to always have an integer gear ratio overall. So you wouldn't say get the necessity much for a 13-leaf pinion or something that's going to give you a funny output through the wheel train. There are requirements, of course, in astronomical work and in moon phases displays for funny numbered wheels and pinions, but generally for the high-grade work like that, the clockmaker would have made his own in the same way that I described one could make a pinion these days. But for run-of-the-mill clock work, making your classic grandfather clock, if you like, or long case clocks and domestic clocks, this would have been standard material, and there would have been many hundreds of thousands of, if not millions of pieces of material like this produced by the tool makers and dealers of the day. Bear in mind also that steel itself wasn't that freely available until comparatively recently. Much ferrous material was wrought iron, perhaps until the Industrial Revolution or until the late 1700s. Not easy to get good steel until quite late in the day. And so drawing a piece of material through a die is less wasteful perhaps than cutting it and milling away and having lots of chips going into the waste bin. So to me that was a fascinating buy, and at £2 I'm really pleased to own it, and I don't think I shall ever use it, but as a document of history I find this absolutely fascinating. So related to that, I at the same fair picked up this beauty. Now to me this is an amazing artifact. I had arranged with a dealer to collect this from him on the day, so it wasn't just a find, but he contacted me because he knew I was looking for one. I put the word out that I was looking for such a thing, and he put the word out. I put the word out and he contacted me. And what this is a watchmaker's sector. So it's a gauge, and if you look closely you can see that it's marked from 6 down there in equal increments, all equally spaced numbers, stamped both the same on both sides, on both limbs, going all the way up to 105. And you can see in this section closest to the joint that the tool is chamfered, and that there's some steel little inserts put into this small section here, because presumably first of all the leverage, if you press on something in that little gap there, is quite great if you have something in the gap and then you squeeze the upper end. So the risk of damaging the part and the instrument is greater down here than say it is higher up. Also for the precision of divisions, basically the steel is more durable, and it may be, I don't know if it's visible in this camera's resolution or not, but the lower numbers between 6 and 12 are divided into quarters. So you've got 6, 6 1/4, 6 1/2, 6 3/4, 7, and so on. And this tool would have been used when matching wheels and pinions together in building a watch. A clockmaker would have had the same thing, only much bigger. I mean, that's not an uncommon size clock wheel. That's a modern clock wheel of my own construction. You can see that it is much bigger than the tool will allow. And in fact, I think this is 80 teeth, and 80 on the tool is up here. So you can see it's much bigger than the capacity of this instrument, and so a clockmaker sector would be much bigger. It would have been a common requirement in the days when this tool was current to have to replace a damaged wheel or pinion in a watch, and this is what this tool would have been used for. So if you think about it just briefly, if you have a pair of wheel and pinion mobiles where one is driving the other, and we have a gear ratio, say there's 60 teeth in this wheel and there are 10 leaves in this pinion, so it's a 6-to-1 gear ratio. So that's quite straightforward. But what may not be immediately apparent, but is quite logical, is that not only do the numbers of teeth have to follow a certain ratio, but their respective diameters have to follow the same ratio in order for the thing to function at its best. And so you've got 60 teeth here and 10 leaves there, so it's a 6-to-1 ratio. Then you also need a 6-to-1 ratio in the diameters. And so that's what this tool would have been used for. So in making a clock or a watch or replacing a missing mobile, what would have been done was you would take, say you had the pinion. Now I counted these previously and I've forgotten what they were. I think, yeah, this was 60. And that, so what I've got here is a couple of wheels from a little carriage clock. That's the contrate wheel. You can see the teeth are on the face. So that would have, that turns the action through 90 degrees. But that's the contrate wheel, and I think that's the third wheel of the clock. And they gear with each other, they mesh with each other. And that's got 8 leaves, I counted them earlier, and this has got 60. And these come out of a working clock, of course. Not a very high quality clock, but it is an antique little carriage clock. And so say, for example, this wheel was missing and I had to replace it. And I knew from counting all the numbers of teeth in the whole train that in order to finish the pattern, I'd need a 60-tooth wheel. And I knew that it mates with an 8-tooth pinion because I have the pinion in my hand. I mean, I have it. It's left behind. It's extant. So what we do is we put this against the limbs of the sector until the diameter comes out at the 8 mark. So then I fasten the thumb screw. And I'm going to put my eyeglass on just to make sure that it's going off camera. Right, so in fact I can close it up ever so slightly, and so there's a fine adjustment here. And you turn it towards you to close. So we'll try that again. Now I already know what the outcome is because I've done this before starting the video. So what we have is, we know there are 8 leaves in the pinion, and I have put them in, I've gauged them so that the opening of the sector, this angle, fits, that the pinion fits exactly between the 8 mark down there. So then anything that gears with this, any wheel that gears with this of any number, that wheel would have to fit perfectly in that space there. And so if I were looking, say, for replacement wheels, say I had a whole stock of wheels that I could, borrow, I just fit it in there and say, well, actually this one is about 53, so it's a bit small. And I go up and up and up until I found one that jammed exactly at 60, and then I know it would be ideal. So anyway, it'll hardly ever be required to be used. I've never seen one for sale before, and yet it must have been a very common tool in its day. The problem is, it's the kind of thing that isn't immediately apparent as a horological tool. It could just look like some kind of pair of rulers or something. And so, just like antique screwdrivers, horological screwdrivers, which one never sees, the proper old ones, I'm not talking about ones from the 1920s, I'm talking about 200-year-old screwdrivers, they almost never appear. And I think that's either because they get reused somewhere else, or they get ground down and thrown away, or they don't appear to be particularly horological and they end up being used for other purposes. They get repurposed. And I suspect that this could be a similar reason why such things are almost never seen, because they're not immediately obvious as horological tools. So there's an American author called Ted Crom with many volume set of antique tools that he's catalogued, and there's almost the pair to this tool illustrated there. So that's not surprising, because these tools have been made by a select number of tool makers, if not made by the clockmaker himself. And so the same tool maker would have made things to the same pattern for many decades or even hundreds of years if the company stayed around that long. So that's why when you see one, it'll probably look like this. So I was very pleased to pick that up. I paid an absolute fortune for it. I was very pleased to own it. In fact, I'm going to leave it a bit open just to avoid damaging this arc. So I'll leave it in that position for now when I store it. So that's it. So that's the piece of pinion wire, the sector. I found this little leaflet, which is a beautiful, I think, 1950s instruction manual or advertising leaflet or guarantee card, perhaps, for a Belova Accutron. And it's beautiful. It's got metallic ink. It's got this kind of Sputnik spaceship printed on the front cover, and it shows the electronic workings of the device. Just imagine if the most technological things we bought today showed us the inside rather than the outside. I mean, you wouldn't expect to see the inside of an iPhone used on the front cover of the iPhone catalog. Whereas in the 50s, this was regarded as high technology, and indeed this was cutting edge of science. And so they're very proud to show the mechanism on the front cover. And presumably people who bought this watch fancied themselves as quite geeky, if you like. They understood about these sort of things, and so this would have appealed to the sort of person who might have bought a Belova Accutron. So this was given to me for nothing. I just said to the guy, "Oh, how much is this leaflet?" And he said, "Oh, you can have it." It's just shoved, lying in the bottom of a box with some, big box of watch parts. So that was that. That was for nothing. Beautiful. I do have a good collection of horological printed paraphernalia, and this fits perfectly into the rest of my collection there. Moving on to something quite different, I have here a handful of taps and dies. So these are very interesting to me as a watch and clockmaker, particularly because of their size. A lot of them signed made in England. And so what we have here are very small BA sizes. So BA is a defunct thread standard called British Association, and was the sizes of the threads were very good for instruments, clocks, watches, and used for much of the 20th century. Of course, they've been superseded by the metric standards, but in fact the BA threads are a metric thread expressed in inch terms, and so the threads themselves were defined in metric fundaments, but then published, in imperial units. And so the smallest one I've ever seen before now was a 12, and so that's a 12 BA. So that's probably, I've got a chart, I can tell you exactly what that size is. So my little Zeus guide, which is a little sort of pocket guide for, all this kind of data, gives BA standards there, and the smallest it shows is 12 BA, and the tapping drill for 12 BA is 1.05 millimeters, or 41 thousandths of an inch, and the clearance drill 1.4 millimeters. So that's a 12 BA. That's the smallest I've ever seen. However, in this selection of parts, there's another 12. That's a 5. So also, it's not that common to find the odd numbered sizes. So normally you find even numbers. This one's a 9, and this one is a 10. So in some of the work I've been doing, I recently had cause to try and find a 12 BA tap and die. You can buy them, on eBay and from model engineering places and that, but they all seem to be made in India or China or something. And in fact, out of 3 dies that I bought, 12 BA dies, no name, no statement of where it was manufactured, of course, 3 were absolutely useless, and I had to throw them in the bin because the threads didn't even align, and so the die itself stripped the thread as it was being made, because for some reason, must be in the hardening process or in the slitting process, something sprung, and the cutting faces kind of misaligned enough so that as the work came round, what had just been cut got torn up by the next set of cutting faces, and they were all like that. They're absolutely disgusting. I threw them straight in the bin, and in the end I managed to find an old one from a vendor in Denmark, and it was a good £15 worth or something, £20, and a few days later it turned up in the post, and that was good because it was an old English-made die. These a lot of these are sign made in England, and they're obviously old, 1950s or 60s perhaps, and obviously all very good quality. And I've never seen the very small sizes. Of course, I don't have the taps. I couldn't make taps using the dies. A lot of these are split dies, so I could open them out slightly or pinch them in. I can't remember which way around, but I could make some dies, some taps out of the dies if need be. But what was a pleasant surprise again was the seller's price. Now, I know the guy who sold these to me quite well. I bought quite a few things from that particular tool dealer, and he knows what to charge, and I fully thought he was going to really go to town with the price. And they were something like, for these sizes here, up to 10 or something, they were like £3 each, and the other ones he said, "Oh, I'm really sorry, but I'm going to have to charge you £4 each for the others." I was like, okay, fine. Probably less than I would have paid in total, less than I would have paid for 2 from certain dealers on eBay, and I wouldn't have gotten the quality. So I was really pleased to get this handful of very small BA dies, and they are going to go into my box of taps and dies. Of course, I do have a very good selection of metric taps, horological taps and dies. They're very hard to come by these days. Even the Bergeron ones are not easy to find. But I do have a good selection, and I do have a good selection of Martin taps and dies, which are the old Swiss scale, and they come normally as taps with a screw plate. So where all the dies are, formed in one plate, just with differently labelled holes. So I was very pleased to procure that. Then on the way into Kosmos today, I found in the street a 24-inch scale, and that's great. I don't have a long rule, steel rule. It's not quite a yardstick, and there's a little bit of something going on there, like somebody's used it to you know, make some kind of sharp edge, but it's fine. It's not signed, doesn't have a name, but it's a stainless rule, so it's probably, you know, fairly modern. It was just lying in the street like somebody had thrown it out. So, great find. I mentioned about lots of information about wheels and pinions, and so something else I picked up, but not at the market, but I picked it up quite recently from a friend who's an older horological toolmaker in Sheffield. His name's Malcolm Wilde, and in fact Malcolm Wilde was the designer of that overhead milling spindle, milling drive that you've seen installed over my lathe, and he supplied all the castings for that. And so this is one of the other tools that he makes, and he offered this to me lately. There you can see his little label on the lid, JMW Clocks in Sheffield. Still going, although slowing down now. I think he doesn't want to do that much of this type of thing anymore. And so I procured this from him lately. I don't suppose I'll get that much use for it. It is an accessory to the clockmaker's depthing tool that he also builds. So this is a depthing tool. This is a watchmaker size depthing tool. I'll describe what it does presently, but that's what the sized for watches. This is sized for clocks, but as I say, this is an accessory, and this is for depthing contrate wheels for verge clocks. So somebody non-horological, that probably sounds like Chinese, and so I will show you. So in any event, this I picked up very recently, and I had already procured from him before the clockmaker's depthing tool. I have various accessories there, something else. So that's the clock-sized instrument. I'll just get this out of the way. So, beautifully made instrument. And what this is used for, so you can see it's got a thumb screw and a fairly stout spring, a leaf spring, to separate or bring together the two limbs of the tool. And so this is an accessory which you have to screw on and attach to this tool. And basically it allows you, remember I showed a watch type of contrate wheel here where you've got the wheel with teeth off at 90 degrees to the body of the tool, which would gear with something like that, although not exactly this wheel, but you know, it would be arranged in that layout. And so what this tool does is helps you decide on the center distance of a pair of gears. And so if you had two gears, if you wanted to know how far apart they needed to be, you'd install them in the contrate, in the depthing tool, and I'll show you how that works. So what we've got is some female centers. So I need to find another female center out of the accessories kit. Yes. Right. So we install one wheel with no shake, no freedom, just freedom to turn, but absolutely no wobble allowed. And so then we separate the limbs quite profoundly, and then we install the other one. This isn't perfect because that doesn't have a center, it's just got a flat end. But we'll just mount that in place also. And then what we will do is just open these up and just line up the wheel with a pinion with which it's meant to engage. No, let me think. No, that's wrong. Because in horological work, the wheel is the driver. No, the wheel is the driver and the pinion is the driven. So I need to, and this is the driving wheel because it's bigger, it's stronger. Let me just start again. So you've got the driving wheel there. That's the driving wheel. Oh, I think, yeah, I had it right in the first place. Sorry, I'm rambling here. Yes, that's still correct. Okay, so that drives that. And so I just wanted to line them up so that they're in line with each other. And then, slowly, using the screw, bring them into engagement. And then under an eyeglass, you kind of study the action. So that's too shallow because you can feel it's kind of notchy and it jumps from tooth to tooth. So I'll just disengage them ever so slightly. No, that's too shallow. That's better. Of course, don't forget, I'm not getting a true reading because of that square end. Anyway, so under a glass, you'd study it. And in fact, what I would do is push this over until I could see just the faces. So the face of this pinion and the face of that wheel perfectly lined up against each other, so I could really study their engagement under magnification. And once I was satisfied that I had the ideal engagement capable of being attained, I would then proceed to scribe the relative positions on my workpiece. And so turn the thing end on like that, and so use it as a compass or as a scribing tool, basically to scribe my center distances on the clock plate, so they could then be drilled, and then when these are mounted, they would be mounted in at the correct center distance. And so this accessory does exactly that, but for a contrate wheel. So it allows us to engage two wheels at 90 degrees to each other and get their relative center distances. And so you install it on the tool like that, and so you mount a wheel in that space and another one in that space, and that way you can, by moving this limb, you can bring one wheel towards or away from the other. And so that's something I picked up from Malcolm Wilde lately. So there's another type of depthing tool here that I took out of the box earlier. This is one of Malcolm's creations also, and this one he calls the Pinion head depthing tool. So the way this works, I'll just free everything up. I don't know my own strength. I'm not sure that's actually meant to. Okay. Right, so this is a different type of depthing tool. And the way this works, he calls this the Pinion head depthing tool. So earlier I pointed out that clockmakers would have made pinions out of a piece of pinion wire, a stick of pinion wire like this, and they literally have turned away all these leaves and turned them down to the core diameter of that piece of stock, and left the active zone intact, and then turned, so basically you're turning the entire thing, everything that can be seen out of steel there would have been made out of one piece of metal. Right. Some clockmakers today choose not to work that way because it's quite wasteful of material, really, to turn down a big piece of bar for much of its length, and leaving only, say, a couple of centimeters or a centimeter wide block out of which to cut the teeth. So yes, that's it there. Let's tape it, of course, so it can only go on one way, that way. Right, so if you can imagine turning down that diameter to that diameter, it's all doable, but it's quite wasteful of material. And so some clockmakers consider it better practice to have the arbor in one and the pinion separately. And so the way this clock is being constructed is that we have a brass collet which is silver soldered onto the underlying metal. Then that's all turned true. There's a very slight taper put onto this section here, and the corresponding taper is cut into the steel blank, so that when they're all assembled, they are absolutely concentric and lie very tightly. And you will notice that there is a set of 3 holes, little screw holes, and so the wheel will be fitted up in between this whole assembly. Can't remember which way around it goes. And the screws will bind everything together from that side, 3 little screws. So that's how work would have been done on high-class English regulator clocks in the 19th century. And so in order to depth this kind of pinion, obviously it wouldn't work on that tool that I've just shown over there. This is called the pinion head. It's just called a pinion head. And so we're given a little Allen key here, and so we can unlock that, and so we can adjust the height of this this extension, and so we set it so that it's level. So basically the tips are lying on the same plane. And then we have to make bushings. So we make, that looks like 1/8 or something steel, or maybe a bit smaller. And then so we install a bushing over there that will accommodate that pinion head perfectly without any freedom. And on the other side a similar bushing for the wheel, right? And then we bring them towards each other, and then we can study the action again. Of course I don't have the bushings here, so I can't illustrate it perfectly, and there's a fine adjustment that one can inch along with this screw here with it. And then once you've got your ideal pitch, center distance by observation, you then use this as a scribe. Or in fact you'd use the fat one in an existing center hole, and you'd use the skinny one as the scribing tip. So that's an alternate way of depthing clock gear teeth. So of course this is all in making new parts, really, or making new clocks. But of course it would be appropriate, if one were restoring an antique clock, to work to the same techniques as those used in the manufacture of the clock originally. And so if we had a proper antique clock that had solid pinions, and if it was unavoidable that we had to replace the entire pinion, well then I probably wouldn't use a piece of pinion wire like that, but I certainly would mill the pinion out of a solid piece of steel rather than a loose pinion head. On lesser clocks, remember I said over here we've got a taper and 3 screws, etc. Some clockmakers choose to solder this on place, into place, and others will Loctite it. So those are all, Loctite is sound engineering adhesive, but I'm not sure it's appropriate to horological work. But anyway, that is how some workers will attach the pinion head to the arbor. Anyway, that's just a little aside from this kind of flea market chat. So one thing I'd love to point out is the beautiful fitted case that this tool is supplied in. Really, I think I'm a bit close to the action here for you to really appreciate it, but being based in Sheffield as he is, Malcolm used for his boxes, for all the tools that he made, you know, they all come in these beautiful fitted lined cases. And Sheffield, of course, was England's centre of steel making, and as a consequence it was also the centre of cutlery making. And so all the cutlers would have had special fitted cases for all the boxes of cutlery that they would make. I forgot the word now. It's a canteen, a full canteen of cutlery, like a whole, you know, 12 spoons, 12 forks, etc., etc., and all fitted and beautifully lined in velvet. And so all of his tools come in these specially fitted cases with you know, brass hardware, you know, little recesses for everything to fit into, little hinges. Of course, these, I wouldn't say they're the finest quality hinges I've ever seen, but they're classic little fitments that you might find on a good quality fitted case like this. And certainly one doesn't see anything like this being made anymore these days. And in fact, Malcolm told me that the guy he uses is also in retirement and no longer fancies doing this kind of work. So really we're seeing the end of an era. This is the conclusion of that generation now. When these guys cease working, it's highly unlikely that we'll see work of this quality again. Of course, it could be reinstated for you know, by interested people. But what we're seeing here is the product of men who actually did it for a living throughout the 1950s and 60s, when this sort of thing was at its peak. So beautiful fitted cases. Oh yeah, I should probably point out that in all these demonstrations I've been using this wheel and this pinion as though they were meshing with each other. But in reality, that's not the case. This particular pair is mounted on the same arbor, and so they would never be called to come into mesh with each other. I was just using them as I happen to have these handy, because they're being, you know, being made. So I was just using that to illustrate how one might depth two components like that together. In reality, they would in fact be sandwiched in a stack like that, with an entirely different wheel and pinion mounted beside them. So I mentioned I've been watching some very interesting videos on YouTube, and one I can definitely recommend is a chap called Adam Booth. I think his YouTube channel is called ABOM79, or is it ABOM78? I think it's ABOM79. Adam Booth. He's he's based in America. Lovely, modest man, very skilled, and if you fancy at all things about turning or fitting and turning or machining, as Americans like to say, then I would definitely advise watching his channel. And something he mentioned the other day, and I forgot exactly what the context was, but it had to do with a particular type of wood called lignum vitae. And I can't remember why he mentioned lignum vitae, but it got me thinking that I've got some lignum vitae, and it has a very, very interesting property. So lignum vitae is of particular interest to clockmakers because it's a type of wood that's incredibly dense. It's not the densest wood, but it is very dense, and very interestingly, it is self-lubricating, and so was used in some specialist types of horological work for bearing surfaces and for some moving parts that avoided the necessity to have to lubricate those parts, because the wood is kind of self-lubricating. Now, lignum vitae was used in, it must have been in its hundreds of thousands or millions of components in the golden era of shipbuilding, because it was used at sea very extensively for block and tackle, because of its self-lubricating properties, and because it's not attacked by the damp air found at sea. But it has another very interesting property, and I've just got this this jar here, and I do have some lignum vitae or lignum vitae, and this is it. It is the material used to make traditional lawn bowls. Because it's very hard, it resists the action of the bowls striking each other. Very, very sturdy. And also, because it's very dense, you can contain a lot of mass in a small space. So that's an antique lawn bowl made of lignum vitae. And so here's another one that I'd sliced previously to play with. I've never actually had cause to use it in anger, if you like, and neither do I play lawn bowls. A bit young for that. And I've not had any cause to use it in horological work. But I did slice a piece off just to see if the legend is true. And the legend, of course, is that it is one of the few woods that, when you put it in water, it doesn't float. That's how dense it is. Lignum vitae sinks in water. Such is its density. And so that, watching Adam's video sparked my memory that I have these couple of bowling balls. In fact, I had some more. I bought a little bag of bowls 5 or 6 years ago now, off eBay, and I gave the other balls to some friends. One friend in particular is a specialist in the type of horological work that requires the use of lignum, and you can't buy it new, really. I don't think it's extinct, but you know, it's not really for sale these days, and so in some sense it's a shame to slice up old bowls, but if they can be repurposed, more the better. In fact, I'm always on the prowl, scouting around for mislabeled horological equipment. And in fact, I think this is a perfect example of mislabeled horological equipment. Somebody thought it was bowling balls, but in fact, it is raw material for grasshopper escapement pallets and bushings. Well, anyway, that's it for now. I hope you enjoyed watching that. Sorry to ramble on so, but I hope you've gotten something out of that little video, and yeah, do come back next time.